Sorry?
Ma'am, are you sharing your screen?
Yes, I'm sharing. Now I have shared. I'm just going to share the whiteboard with you, not else, anything else. Written content is not there. The whiteboard is visible for you?
Yes, ma'am.
Yes, ma'am.
Good. So first of all, what do you mean by haloalkane and haloarenes? We have to see. Fine. I'm going to take this word alkane. Right. Alkane is your grade 10 events, right? Yes. Yes or no? Are you there with me? You have to respond, girls.
Ma'am, your voice is breaking.
It's breaking how it shouldn't break. Actually, I have arranged really good Wi-Fi.
It's still breaking. It seemed like yesterday.
Oh, fine. Wait for a few minutes. It may be like audible properly after some time. Maybe. Okay. Maybe it take time to set. Yeah. Okay. Now see here, alkane, we have already learned in your grade 11th and even in grade 10. It has a general formula CnH2n plus 2, correct? Yes or no?
Yes, ma'am.
And this N is nothing but what? Number of carbon. Right? And we have a homologous series for the alkane as well. That is what started with methane, then the ethane, then propane, right? And each consecutive member is differ with CH2. Yeah, with mass number 14 units. Isn't it?
Yes.
Yeah.
Yes.
Now, haloalkane or haloarenes. In this but haloarene, what do you mean by arene? Arene is nothing but what? Aromatic compound.
Ma'am, aromatic compounds like benzene and all.
Yes. So you know about the benzene structure of benzene, must be aware, right? You are. This is the structure of benzene which has an alternate double bond. Yes. Yes. Each corner represent the carbon. Yeah. What is the hybridization of this carbon? Can you tell me?
Ma'am,
You might have learned in your grade 11. And this sp2 hybridize. What? sp2 hybridize.
it's
Whenever
sp2, right?
carbon bonded with another carbon with a single bond, when one carbon bonded with the another carbon with a single bond, this has a hybridization sp3. And when one carbon is attached to another carbon with double bond, that is what? sp2 hybridized. Now you may think like one side is bonded by the double bond, other side it is bonded with a single bond, and why you're calling it as sp2 hybridized? This question might be arise in your mind. Yes. Why happens? Because these alternate double bonds are Aditi, just a while, okay? Screen is visible now? Aditi, have you joined?
Yes, ma'am.
Yeah. I'll just change my position. Maybe because of that, things are not good enough. Give me a while. I'll extend the class, okay? Don't worry about it.
Yeah, sure.
Am I audible now?
Yes, ma'am.
Fine. Screen is visible to you?
Yeah, it is.
Fine, fine. No issues. Now see, haloarenes I was explaining, right? And about the arenes, aromatic compound or aromatic rings are called as what? Arenes. It has an alternate double bond, correct? Isn't it?
Yeah,
And
covalent
it
bond system.
obey the Huckel's rule, right? What is the Huckel's rule?
It should have a
Right?
constant
The
bond, and it should have 4n plus 2 pi bonds.
Ma'am, you're sharing the screen. It's totally blank.
Yes. 4n plus 2 pi electrons. Correct? Where n is nothing but any integer. Hello?
Yes, ma'am.
Yeah, you're audible.
Fine. Yeah. So n is nothing but what? Any integer. So now sometimes we consider it as a number of rings. So benzene have how many rings? One ring. So how many electrons should be present in this? 4 into, yeah, 4 into 1 plus 2. That is equal to 6 pi electron. Right? How many? 6 pi electrons. Aji? Fine. Now see 6 pi electrons are present in this or not, that we have to see. One double bond consists how many electrons? 2 electrons. Right? So how many double bonds are there? 1, 2 and 3. So 3 double bond consists what? 2 into 3, that is equal to 6 pi electrons. Correct? Got it? Yes or
Yes.
no?
Yes, ma'am.
Yeah. So it obeys the Huckel's rule and hence it is aromatic compound. So in this chapter, we are going to see haloalkane and haloarenes means one of the hydrogen of alkane or arene would be replaced by halogen members. What are the halogen members? What are the halogen members? Can you tell me?
Boron, chlorine, bromine, iodine.
Yes. Halogen would be a 17th group in the periodic table. You might have learned, right? 18th group would be the noble gases, right? Yeah, and 17th would be halogen. It is started with the fluorine, bromine, iodine, isn't it? Yeah. You have learned about the trains as well. going top to bottom, going left to right in the periodic table, isn't it?
Yes, ma'am.
And what you know that fluorine is the most electronegative element in the periodic table. Yeah. Now, when we move top to bottom, what happened in a train's atomic radius increases. These all things you have learned in your grade 11th, I guess, isn't it?
Yeah.
So fluorine is the smallest in the size and iodine is the largest in the size. Correct? Yes or no? And we have an alkane. In an alkane, if one hydrogen is being replaced, suppose any one example I'll take. Generally, we can write it RH as an alkane. If this H is replaced by any of the halogen, right? And halogen would be considered as a X, right? If it would be replaced by X, then what you will get? RH plus H. That would be plus, minus, it will go with another reagent, right? So these reactions we have to learn in this chapter. Means like how alkane, alcohol, then any another basic general members would be converted into haloalkanes. Their preparation, their properties, that all things we are going to learn in this chapter. But then before going to learn all these preparation methods and all, we should know how we have to classify these haloalkane and haloarenes. What about the arenes? We know about the benzene is an aromatic ring, right? This is alternate double bond. Each and every carbon has one hydrogen in it, isn't it? If that one hydrogen would be replaced with any of the halogen, right? That will be converted into haloarenes, right? Means H should be replaced with X. This X would be what? Either fluorine, bromine, or iodine, right? But then before learning all these things, you should aware fluorine, bromine, and iodine. These are what? Diatomic molecule. How it should be? Diatomic molecule means what? Aditi, Chandana, what do you mean by diatomic molecules? Means whenever it will be form molecules, those molecules have
molecule with itself, right?
Yeah, it must contain how many atoms? 2 atoms.
2.
Yes. So diatomic molecules. It will not be exist as a F only. It will not be exist only Cl, right? Because they are in a nascent form and unstable. So it may always present in a F2, Cl2, Br2, and I2 form. Got it? These things you need to keep it in your mind because while writing equation, this is very, very important. Fine. Understood about the what is exactly haloalkane and haloarenes? Means from the aromatic ring or from the alkane member, one of the hydrogen you have to replace with what? Halogen. And those halogens would be chlorine, bromine, or iodine. Clear?
Yes, ma'am.
Yes, ma'am.
Any doubt?
No.
No, ma'am.
Doubt? Okay, fine, no issues. Now we'll move to the next point, that is a classification, right? Classification of haloalkanes and haloarenes. Haloarene will keep aside. First of all, we'll go for the haloalkanes, right? So on the basis of the halogen atoms, these may be classified as a mono, di, or polyhalogen, right? Monohalogen haloalkanes or mono haloalkanes, then dihaloalkanes, then trihaloalkanes, then tetrahaloalkanes. But then after tri onwards, it consists as what? Polyhaloalkanes. Okay. And this is basis of what? Number of halogen atoms present in the compound. Right? For example, I'm going to write it here, C2H5X. How many halogens are present? Only one. Means this is a parent ethane. C2H6 is what? Ethane. This is a parent ethane, right? And one of the hydrogen means the H5 becomes sorry, H6, and one of the hydrogen is replaced with what? Halogen. And hence it is monohaloalkane. What it will be? Monohaloalkane. Similarly, CH3. This is also ethane. So from here, if I remove one hydrogen and attach one halogen, here I have removed one hydrogen and attached one halogen. How many halogen groups would be present in the on the ethane? 2. So it will be what? Dihaloalkane. Got it? Yes. Now with the propane member also you can attach 3 halogens. That would be trihaloalkane. Can you draw that structure? Yes. Yeah. CH3, CH2, CH3. What is this? Propane. So from here, I'm going to remove one hydrogen. I'll attach one halogen. From here, I'll remove one hydrogen and it will be replaced by the halogen. Here also, I'll remove one hydrogen, replaced with the halogen. This will be what? 1, 2, 3. 3 halogen groups would be there. This is trihaloalkanes. Got it? Fine. Am I audible, girls?
Yes, ma'am.
Fine.
Yes.
Now, what about the arenes? Shall I clear this?
Yeah.
Yes, ma'am.
Fine. So what about the arenes, aromatic rings you have to draw, right? In this, if one hydrogen would be replaced with halogen, that will be monohaloarene, right? And if 2 hydrogens would be replaced with halogen, that would be what? Dihaloarene. And whenever 3 hydrogen would be replaced with halogen, 3 hydrogen, if replaced with halogen, then that would be trihaloarenes. Fine. Yeah. Now we are going to see a basic classification of alkyl halides or haloalkanes. We are not going to turn towards the haloarenes. We will see the basic classification of alkyl halides or haloalkanes. Fine. If you are writing, please write down classification of haloalkanes. Haloalkanes has another name, that is alkyl halides. Commonly we called it as alkyl halides. This is also you should be aware because most of the time common names also used, right? And in IUPAC we say it as a haloalkanes. What do you mean by IUPAC? Are you aware of?
Yes, ma'am.
Yeah, please tell me if you know. IUPAC means International Union of Pure and Applied Chemistry, correct?
Yes, ma'am.
What it is?
International
this?
Union of Pure and Applied Chemistry, Organic Chemistry.
Yeah, what is this? That's what I have told you, long form, but then it must be something. For that only we made its abbreviation as IUPAC. What exactly it is? That's what I'm asking you. This is an organization,
It's something like
worldwide
which
accepted
verifies.
organization.
It's an organization which verifies the chemical, so everything related to chemistry, like
Yes.
giving general names
Yes.
and all those things.
It also standardizes the methods for measurement and atomic weights and many other.
Yes, very good, very good. Means you're aware. So this is an organization which decide the name of a chemical which decide the name for newly discovered element, which decide the physical quantity units, etc.
Like
Right?
it
And
gives the
whatever
perfect
yes,
like it gives
whatever,
perfect terminologies for everything.
yeah, true. Understood? So this IUPAC nomenclature is the worldwide accepted, and in that way, how we are going to nomenclate it has a haloalkanes. But then generally, haloalkane is called as what? Alkyl halide. For example, if I write it here, CH3Cl, what is this? Methyl chloride, I will call it in general, right? But then its name would be chloromethane, according to IUPAC. Got it? Yeah?
Yes, ma'am.
Fine. So shall I give you a few examples? Can you do that? I mean, say, can you write down the names? Let me see whether you understood or not. So what? Methane is the parent and attached with the chlorine. So common name would be what? Methyl chloride. Yeah. And its IUPAC name would be what? Common name this would be. And IUPAC name is chloromethane. Fine. So I'm going to give you a few examples. Let me see whether you are able to do it or not. Go for this. Tell me the name, common name, as well as your IUPAC name for this.
Propane. That's the IUPAC name.
Bromopropane. Okay, IUPAC name clear. Very good. Here, 1, 2, 3 means parent would be propane and attached with the bromine, and hence it would be bromopropane as per the IUPAC nomenclature. Very good. Now, tell me about this common name. It's a straight chain alkane, which is attached to the bromine, right? So this is normal N.
Propyl bromide.
Very good. This is N-propyl bromide. What about this?
2-chloropropane.
This chlorine is attached to the second carbon, right? So
That's
commonly it is called as
2-chloropropane.
isopropyl chloride. Got it? Understanding? Whenever of the halogen, any of the branching is done with the secondary carbon, not secondary, second carbon in the chain, that is called as the isopropyl chloride. But then it must consist at least one hydrogen. And when there won't be any sort of hydrogen, that time it would be neo. Okay. When one hydrogen would be there, this would be iso. And when there won't be any sort of hydrogen, that would be neo. Keep it in your mind.
Okay, ma'am.
Clear? Fine. So this is isopropyl chloride commonly, and its IUPAC name would be what? If I write the chain 1, 2, 3, at the second carbon, chlorine is attached. So it will be what? 2-chloropropene. Got it? Fine. Now one more example. Sorry. Fine. I'll clear this. One more example I'll give you. Let me see whether you are able to do it or not. CH3, CH, CH2, Cl, and here also CH3. So now see how many carbons are there. First of all, you see commonly 1, 2, 3, 4, right? Whenever 4 carbon would be there, that is a butane, right? But then this branching is happen at the second carbon. If we see the chain 1 and 2, hence it would be isobutyl chloride commonly, correct? Now IUPAC nomenclature would be what?
1-chloropropane.
Second, third. So your parent became what?
1-chloro, 2-methyl propane.
Propane, right? 1-chloro, very good. 1-chloro,
2-methyl propane.
Yes. 2-methyl propane. Very good. Once you understood about it clearly, isn't it? Fine. Now we are going to see the nomenclature for haloarenes. Shall we go for it?
Yes, ma'am.
Fine. Okay, very good. Now, this is a benzene, correct? Isn't it? One hydrogen is replaced with bromine. What would be the name? Commonly and IUPAC name for this compound would be same.
Bromobenzene.
Yeah, this is what? Bromine, and this is a benzene. So it is bromobenzene. Very good. Then the next one. Come on, tell me the names. Now, before writing the common name for this, I'll let you know the position into the aromatic ring. Okay, this is your
Ma'am, the second one is 1,3-dibromobenzene, or also known as meta-dibromobenzene.
Yeah. That's what I just wanted to clear you about the position. These are the alternate double bonds. Okay. Suppose here any of the substituent there, I'll consider it as A. Okay. This position next to the substituent is called as ortho position. What? Ortho. After ortho, this position is called as a meta position. And the next to the meta position, this position would be para position. Same for the another side as well. So the next to the substituent would be ortho, right? And next to the ortho, it would be meta. Understanding this we use for the common nomenclature or common name. Okay. So here you can see this Br is one substituent. This another Br is another substituent, right? There are the two substituent at which position? Meta position, right? Yes or no? Yeah. So what we come to know? Meta, di why? Because two bromines are there. Meta, di, bromo, benzene. Got it?
Yes, ma'am.
And what would be the IUPAC nomenclature? When you have to go for the IUPAC nomenclature, you should number it. One of the substituent would be first, and another you have to number 2, 3, 4, right? Either from this side or from this side. But then obviously you have to keep in your mind numbering should be always from the side of the branching, right? So this side the number of substituents are more as per this side, isn't it? Hence we have to number in the clockwise manner instead of anti-clockwise manner. Got it? If this BR would be present this side, that time I would means like number from the anti-clockwise manner. So it would be 1, 3 di bromo benzene. Got it? Now what would be the name for this?
Meta-tribromobenzene.
It is 1,3,5-tribromobenzene.
Very good. Both are correct. Right? Meta tri bromo benzene. And this is a symmetric benzene. You can see that if I wanted to cut it, I can cut into the two equal halves, right? Hence, it is symmetric tribromobenzene also you can say. And that will be what? 1, 3, 5, right? Tribromobenzene. Isn't it? Understood? Yes? This nomenclature you understood or not?
Yes, ma'am.
Are you writing with me?
Yes, ma'am.
Fine.
Yes,
Very good.
ma'am.
Fine. Now, few more basic things are there about this nomenclature, which I actually wanted to explain you. Right? A kind of alkyl halides. Already we have learned about the alkyl halides and haloalkanes. That alkyl halides are further classified into primary, secondary, and tertiary. What it is that I'm going to explain. Shall I erase it? And one more basic question, whatever I'm explaining, whether you're understanding or not, that is very important for me. Yeah, girls?
Yes, ma'am. I'm understanding.
Yeah, ma'am,
Okay,
no
what about
doubts.
you? Fine, no issue. Here I'm going to write a carbon. Suppose this is your R, any general group, alkyl group. Here your carbon, which attached to two hydrogen. Yeah, and one of the hydrogen if replaced with your halogen, means your halogen is directly attached to your first carbon. Then it is primary alkyl halide. What it is? Primary alkyl halide. Okay. What do you mean by secondary? What is the basic difference in between primary and secondary? In this, what happened? This carbon, we know that valency of carbon is 4, right? Means it form how many? Generally 4 bonds, right? If it is attached to 2 carbon, and valence has been satisfied. Instead of carbon, we can say alkyl group, any alkyl group. This is R, here it will be R dash. And instead of 2, only one hydrogen is there. And among that, one hydrogen is replaced with halogen. Understanding the basic difference in between your primary and secondary. This is what your primary means: carbon attached to 2 hydrogen and one another carbon. If it is attached to halogen, that would be primary alkyl halide. When one carbon is attached to 2 alkyl group and one hydrogen atom, that would be your secondary alkyl halide, right? And when your carbon attached to 3 alkyl group, R, 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 that can be similar or different. It depends. And if it is replaced, one of the hydrogen is replaced with halogen, that would be tertiary.
Alkyl halide.
Yeah. Fine. These are the basic things. And these generally replace with the numbers. Primary means what? In this manner. Secondary in this manner, and tertiary in this manner. Okay. Why this is so? Because this carbon is primary carbon, this carbon is a secondary carbon, this carbon is a tertiary carbon. Primary carbon is attached to with only one alkyl group, right? Secondary carbon is attached to 2 alkyl group, and tertiary carbon is attached to 3 alkyl group. Okay, and these are can be same or different. These things you need to keep it in your mind. Understood?
Yes, ma'am.
Now we are going to see about the allylic halides. What do you mean by allylic halides? Allylic carbon means what? See, I'll let you know. If in any compound, if there would be the carbon-carbon double bond. See, any compound, there would be a carbon-carbon double bond.
The
And if
sp3 carbon
attached
attached
to
to one of the double
another,
bonds.
yes. If it is attached to CH2 group, and this would be attached to the any of the halogen. Understanding? So this group, this carbon-carbon double bond is called as what? Allylic group. And this is called as the allylic carbon. Understand? In any of the compound, if carbon-carbon double bond is present, and if it is attached to any of the carbon, that carbon is an allylic carbon. And when it is attached to any of the halogen, that this halide is called as the allylic halide. Understanding? These halides are called as what? Allylic halides. Got it? Understood or not? See, same allylic halides are present into aromatic compound or in the ring compound as well. So how it will be, I'll let you know. Suppose this is a ring compound. In the ring, there would be one carbon-carbon double bond is present. This is the carbon-carbon double bond. So here, how many allylic carbons would be present? You can see this is also carbon, this is also carbon. This carbon is directly attached to double bond. This carbon is also directly attached to double bond. So this carbon is also allylic carbon and this carbon is also allylic carbon. And with this carbon, if halogen is attached, then this would be your allylic halide. Got it? Either at this place or either at this place. It depends. Okay. What is essential condition? carbon-carbon double bond should be there, and that carbon-carbon double bond must be attached to any of the another carbon which is attached to halogen. This carbon-carbon double bond attached to any of the carbon and which should be attached to another halogen. So that would be allylic halide. Clear?
Okay. Yes, ma'am.
Fine. Yeah. So these things you need to keep it in your mind. This is about the allylic halides. Now what about the benzylic group? Right? Yes or no? So benzene, everybody is aware? Yeah.
Yeah,
When
ma'am.
benzene is
Yes,
attached
ma'am.
to when benzene is attached to any of the carbon or any of the methyl group, and among that one of the hydrogen if replaced with halogen, then that would be the benzylic halide, right? This is your benzene, right? This benzene is attached to this carbon, right? This carbon is called as benzylic carbon. And when it attached to halogen, it is called as the benzylic halide.
Ma'am, it can be any hydrocarbon group, right, which is attached to the benzene.
Yeah, any hydrocarbon. It should not be only one CH3 group. It can be any R, general alkyl group. It can be. Alkyl group means what? One hydrogen should be removed from the alkane. That can be propyl, that can be butyl, that can be pentyl. Understood?
And
Means
ma'am, for allylic halide, the carbon should be sp3 hybridized.
yes, that's essential. Yeah. Carbon should be sp3 hybridized. Got it? Fine. Any query about it? Not understand anything?
No, ma'am. Got
Fine.
it.
You tell me whether it is allylic, benzylic, what sort of compound it would be, and which carbon it is. This would be benzylic. Yes or no?
Yes, ma'am, that is benzylic. And is it
Benzylic, okay. Any R group we have considered, right? And this we can check that it is carbon, here alkyl group, here alkyl group. Means this carbon is what? Tertiary carbon, right? Yeah? Yes or no? So this alkyl halide would be what? Tertiary benzyl halide, we can say. Tertiary benzyl halide. Right? Because this carbon is a tertiary carbon. Clear? Yes or no?
Yes, ma'am.
Fine. Now we are going to see about the vinylic halides. What do you mean by that?
Ma'am, could you repeat one?
Benzylic, what we have learned, these carbon-carbon double bond attached to one of the carbon and that should be attached to halogen. And this need to be what? In allylic halides we have learned. This is to be sp3 hybridized, correct? This we have learned, right? But then in vinylic halides would be what? Carbon-carbon double bond, sp2 hybridized carbon is directly attached to your halogens. So this carbon is what? sp2 hybridized. Okay. And it is directly attached to your halogen. And hence it is a vinylic halide. Got it? What is the spelling? Vinylic halides. Few more example I'll give you. Here is a ring system. In a ring system, one carbon-carbon double bond is there. And if directly one of the hydrogen from carbon-carbon double bond is replaced with any halogen, this is what? Your again vinylic halides. Allylic halides are sp3 hybridized and vinylic halides are sp2 hybridized. This is the basic difference in between. Means it is directly attached to, vinylic halide is directly attached to carbon-carbon double bond. Halogen is directly attached to carbon-carbon double bond. And in allylic halides, hydrogen is attached to sp3 hybridized carbon, which is attached to the carbon-carbon double bond. Understood?
Yes, ma'am.
Fine. Now, aryl halides. Now, see in the aryl halides, there are many compounds in which like one of the hydrogen from the aromatic ring has been replaced with halogen, right? Few examples we are going to see. How you have to label them, that already I have explained you. This will be haloarenes, right? What is this position? These two? Tell me.
Para.
Para. Very good. So how are you going to label it? This is haloarenes. For example, suppose this is a chloro. Instead of X, there would be chlorine. Right? How I'm going to write the name? Chlorobenzene. Correct? And what about this? If this X would be replaced with chlorine, then commonly it is called as what? Parachlorotoluene, because CH3 whenever attached to the benzene, it becomes toluene. Correct? What would be the name? Or else you can write IUPAC labeling as well. 1, 2, 3, 4. 1 chloro, 4 methyl benzene. Correct? Yes or no?
Yes, ma'am.
Fine. In this way, you should label it. I hope you understand about the classification. Yeah?
Yes, ma'am.
If any query, if you have in your mind, please let me know. One more basic concept in this, I would like to explain you about the geminal halide and vicinal halides. So what is the basic difference in between that two? I'll explain you. Suppose I'm going to write here any of the general R group and here is a carbon, right? On one carbon, if there would be the two chlorine group, means we know that if I have to write like any of the alkyl groups, so R H I will write or R CH3 I will write. So among this CH3, if two hydrogen, two hydrogen, if I would replace with the halogen. So how I'm going to write here? It will be Cl. Here also it will be Cl, and this hydrogen, middle it will be hydrogen. Correct? Yes or no? Then only your carbon's valency will be satisfied. Correct?
Ma'am, could you repeat once again?
Yeah, sure. I will repeat. See, generally, if I have to write any alkane group, right, R, either I will write RH or I will write RCH3. Correct? Yes or no?
Yes,
Yeah.
ma'am.
So among these CH3, if two hydrogens replaced with halogen, right? Means any of the X. So what I have done, instead of CH3, I have written here Cl, and one hydrogen I kept as it is. Got it?
Okay.
So when if we see this carbon, its valency is what? 4. So 4 bonds are there, there or not, that we need to check. 1, 2, 3, and 4. Correct?
Yes, ma'am.
Yeah. So valency has been satisfied. So in this, what happened? Two chlorine group would be present on the same carbon. Right? Yes or no? So this is called as geminal halides. Right? This is called as what? Geminal halides. Yeah. Apart from that, if I have written here, suppose another R group, I can write any other alkane as well, right? How I'm going to write, I'll let you know. See here. This is one of the important part because most of the time, many of the students won't understand this. This R group, here it will be CH2 attached to CH2 and here again R group. For your understanding, I have written. This is also one of the alkane, right? We don't know this R group. It may be same or different. Do not think about it. Now what we are going to do, earlier what we have done, on one carbon only, two hydrogens we have replaced with chlorine in geminal halides. Now what I'm going to do in this, one hydrogen from the adjacent carbon, I'm going to replace with your halogen group. Any halogen group I will take, either bromine, chlorine, iodine, or in a general, I can write as a X. Understood? So in this, what happened? These two bromine group will not present on the same carbon, but on the adjacent carbon. Adjacent means what? Nearby. Isn't it?
Yes, ma'am.
Yeah. And the vicinity, you might have heard about this word. Vicinity means nearby. And hence, these kind of alkyl halides are called as vicinal halides. Understood the basic difference? Geminal halide means what? Two halogen group would be present on same carbon in the alkyl halide. And vicinal halide means when two halogen groups are present, that is called as vicinal halides. Clear?
Yes, ma'am.
Fine. I hope you understand this in a better manner. Now, we have to see the preparation for this all. You tell me, shall I continue or will continue by evening? What time your period today? Do you have any class?
No, ma'am. Actually, sir said today they have to take a test, but they won't take it.
Okay, for which subject it was?
Physics.
Physics. Okay, which chapter is going on for the physics?
Electric charges, electric fields.
Okay. So I'll do one thing. I don't know about other teachers, but then for my content, whatever I'll teach today, on the basis of that, at least 5 questions I'll post in a test. Okay. You have to attempt it. Tomorrow I'll brief about it, where what would be the answer, and we'll continue for the preparation method. Is it okay?
Okay, ma'am.
Since last 40 minutes, we are conducting class or not?
Yes, ma'am.
Timing is over, no? It's not like that. Means yesterday's class, I told you like it should be compensated. So that happened properly. There wasn't any sort of disturbance in between. I hope you understand clearly.
Yes, ma'am. I understood.
Both of you girls. Chandana, what about you?
Yes, ma'am. I understood.
Chandana only said. And what about Aditi? Aditi, are you there? Is she there?
Yes, ma'am. There's just a power cut at my house.
Okay. You understood clearly whatever I taught today?
Yeah.
Because this was so general, beta. This was so general. In next period onwards, we are going to start with the preparation of haloalkanes. What are the preparation? Then what sort of bond in between the carbon and halogen? Okay, whether it is polar, non-polar, electronegativity of the element, everything we are going to learn thoroughly. Fine. So this was just an introductory period for you, and I hope both of you enjoy.
Yes,
Yeah.
ma'am.
Yeah. Yes. Fine. So we'll meet again by tomorrow, I guess. If I'll ask to the ma'am whether we have to conduct class today or not. If she asks, like, tell me to conduct today again, so definitely I'll give you a reminder. If not, then definitely we'll meet again by tomorrow. Fine.
Okay, ma'am.
Okay, ma'am.
Fine.
Thank you.
Take the time. Take care,
Thanks, ma'am.
beta, and prepare. I'll pose the question. Please attempt it.